far north, Whangarei anyway. And his specialty is imaging the sun and the moon. And he's just done a talk on solar imaging. And for our talk tonight, he's going to talk about imaging the moon. Hopefully, this is getting prepared for next week where we've got a lunar eclipse happening on the 26th. So over to Otto. Thanks very much for coming along.
Yeah. Okay, yes, thank you for inviting me. And it's possibly not such a long talk as the last one. And I want to talk about lunar eclipses and preparation for the lunar eclipse at the 26th of May. That means next Wednesday. And speak about mechanic facts, imaging, my own experience, and then also about present and future lunar eclipses. I'm living in Whangarei Heads, Taurikura, for our reason. It's not far north yet, so it's more Kataya and so on, but it's for Auckland pretty far. It's about almost 200 kilometers from my place, from here. And I like it there. It's direct with the view of the Marsden Point. That a little bit gives some light pollution, but otherwise I have good skies. I see the Mt.Manaia, can also observe the Milky Way. So it's quite a good spot where I'm living. And also, of course, observe the moon as well, image the moon. Last year also with a bigger telescope, with an 8-inch telescope, 8-inch Cassegrain, and the Arbitron Mount AZ Pro. But here I more concentrate on the lunar eclipse and imaging of the lunar eclipse. So that's what's about the moon, a little bit in introduction. It's the only natural satellite we have. It creates also the tides, very important also for us, for life, for the birds. And it's crucial that we have the moon. And it was also, we landed on the moon in '69, we'll keep through despite all conspiration theories going around. Moon is about 3,470 kilometers in diameter. It's about 1/4 of the Earth. And another quirk is the moon, that the moon looks almost a similar size than the sun. And that's great because then we can see eclipses. So not only lunar eclipses I talk about, also solar eclipses. Otherwise, we wouldn't be able to see the coronal solar eclipses. So that's just 400, the sun is 400 times farther from the Earth than the moon. And that's just in the right proportion. That's in 600,000 years that will end because the moon is tending to get about 2 centimeters a year farther away from the Earth, and in 600,000 years the moon is then too small that it covers completely solar disk. So you have then only annular eclipses. So but that's also important to say. And in the moon you would be much lighter, less gravity. So yes, it was a great event, the moon landing. And for imaging in the moon, the craters, you can image all structures. It looks like as you were on the moon when you image the details. It's fantastic. And today I want to talk about the lunar eclipse. Yes, there's a lot of spin around and conspiracy theories. For example, there was, when I came to Whangarei, I'm working since 2014 here for mental health and addiction services in Whangarei since 2014, and there were 4 successive lunar eclipses. There was the big tetrad, call it, okay. And there's one book, okay, in 2015, after all the tetrads, we have the end of the world. And you see, it didn't happen, yeah. we are still here, but there's a lot of stuff going around in that time. Fortunately, we have a resurgence of conspiration and superstition still, and I think also in the US, politics, Trump and QAnon, all that promoted it. So it's quite important to keep science, teach it and educate, and have a counterbalance. So now, that is a red moon. It's reddish, yes. It's a reflection of the stray light comes into the Earth, within the Earth's shadow of the moon. I will show it, and therefore you have this color. And you can only have a lunar eclipse at certain times. That's only when the moon is at the lunar nodes. And the ecliptic of the Earth is the same as with the sun. Otherwise, and that's, yes, otherwise you can't see a lunar eclipse. So that must be on the lunar nodes. Or close to it, yes, close. So that means you have the sun here. Sun shines towards the Earth. It's in a similar plane at the lunar node and casts a shadow on the moon, so-called umbra. But you have also some stray lights from the shadow. That's the penumbra. And then the moon goes within that area, and then we get a total lunar eclipse. Yep.
Why is it light on that side?
That's
daytime.
theta. That's only a graphic. It's a graphic to explain the lunar eclipses here. That's the physics also, the geometry explained. Here you have the sun, the Earth, and then that's the umbra here with the penumbra, and then you have the moon, yes. And the more centered the moon is in that umbra, the longer is the eclipse. And it's also a rule that 2 weeks before any lunar eclipse or afterwards, there's any solar eclipse. So this time we have at the 10th of June an annular solar eclipse in North Canada and in Greenland. So that's always combined. Yeah? So this looks like an annular eclipse, solar eclipse. So that means the moon is not as big as the sun, so you have this so-called ring of fire. But here, in a total solar eclipse, you have the corona there. And of course, solar eclipse is just the other way around. There's the moon there. So that covers the sun, so it's the opposite. So, yeah, the eclipse comes in cycles. Every eclipse has a little bit is specific, and every 18 years, when there's a sort of finish of the Saros cycle, the eclipse is similar. Only in the location is different. It varies a little bit, but it depends on the cycle. You have different kind of months of the moon, synodic months, or anomalistic months, or draconic months, and all these months coming together in simultaneous time at the end of the Saros cycle. That's 223 synodic months. And then you have similar characteristics of the eclipses. Here, that's an example of a Saros cycle from the beginning, 1922, up to next November in 2008, is similar characteristics. The locations similar, very light. And the naming of the Saros cycles as well. This has a nomenclature as well that you can name and this. And here, that's a sort of graph of the lunar eclipse, and that comes from that book. That's sort of the standard. That's the 21st century canon of lunar eclipses from Fred Espenach, the eclipse gurus, and you have here all the graphics of the lunar eclipses there. And from this book, I took some images. And that's the explanation of it. So, for example, that next year, 16th of May, you see it's pretty in the center of the shadow, also of the umbra. So it's a longer eclipse that is explained by the gamma, and takes up to more than 1 hour, the duration. And that's the time is here defined in terrestrial time. That's close to the UT or universal time. So that's the explanations. And here is the visibility. For example, that eclipse is not all too good visible in New Zealand, but we still see the beginning of the totality. So that's at this time. And that's a longer one than the future one, in 1 year. And here, what is in black, you don't see the eclipse at all. And what is in white, you see all episodes of the eclipses. So the types, what types of lunar eclipses we have? We have an idea. So the penumbral one, you see not much. Yes, distinct. The partial one, yes. Let's see a little bit the black there. And when you overexpose it, the partial one, you get this color as well. And the total one has this color, this reddish coppery color. People call it also blood moon. And if you would stand on the moon, you would see this red halo around the moon, yes. So, around the Earth, sorry. When you stand on the moon, you would see the Earth with a red halo. And the color comes from that stray lights, from reflection outside of the shadow from the sunlight. They refract into that Earth shadow, and that makes the color. And likely due to refracting away the blue light, it's more at sunsets and sunrises, you have this color. So, yes, that is a penumbral eclipse, yes, not from Espanol. I have also one image, but that shows it better. The difference is very subtle. It's there. And here, the darkness of the eclipse depends on the atmospheric condition. If there's a lot of dust, like the bushfire in Australia, for example, there would be a very dark eclipse or a volcanic eruption, and that is staged in the Danjon stages. As a 0 is very dark, and L4, what were the last eclipse, is very bright, coppery red, orange, or orange eclipse. And it has often a bluish, very bright rim. And that depends on the atmosphere. Clouds in the troposphere, stratosphere. Will be interesting how this next eclipse will pan out, because we had this bushfire last January. And there's possibly still a haze there. What I mentioned in the talk with the sun, I think the seeing is worse now than, let's say, 2-3 years ago, I think. Especially when I see the processing in the calcium K, before I could do the magic wand tool, and could select. Now, when there's a little bit high clouds and haze, you can't do that. So that interferes. And we see, yes. Hopefully we see it, yes. Any questions?
Just saying that over the last weekend when we were taking photographs up north, just about every image I had a red haze in the sky.
I believe that's some actual phenomena that happens after aurora quite often.
But there was
sky glow.
There was an aurora, I think it was on a Saturday, that was an aurora almost visible up to Auckland, it was all red.
Yes.
There was a solar storm.
We photographed this on Thursday.
Yeah.
We were out at Whitefield Bay, and you set your color balance to what you think was normal, and everything's this brilliant red, and you can actually see the kind of stripes of the season.
So it was our KP7. And it was late at night, because normally I get an alert, but I was sleeping, and it was, 3 a.m.
Excuse me, I know what atmosphere means, but I've forgotten what stratosphere means in troposphere. What do those two words mean again?
Pardon?
T and S.
Troposphere and stratosphere.
Yeah.
So they're higher up. So they're all part of the atmosphere. Different heights.
Troposphere and stratosphere, yes. It's at the height of the atmosphere. The stratosphere is the highest one. And
Stratosphere is the lower one, isn't it?
And troposphere is the lower one, And if there are any volcanic eruptions, they could also go up the ash till to the stratosphere. And that would clearly affect the darkness of the lunar eclipse. Yeah. So here, now we're coming to that eclipse next week. As you see, it's a short eclipse because the moon is not in the middle of the Earth's shadow, it's quite in the rim. So it's only 15 minutes, the totality. The shortest I observed was in April 15, I have a photo. It was 5 minutes. Yeah. So it's pretty short, it's 15 minutes. And the partial phase is about 187 minutes. And the magnitude is quite, also not quite big, the shadow. So yes, it's just a total lunar eclipse. And that's the best one was between 11:15 and 11:30 p.m. you should see. Weather permitting, no clouds. Yeah, yeah. Yeah, and I looked at the 10 weather forecasts today before I came here, and I saw that look, and there in the meteosat, interestingly, Auckland clear, Whangarei was not clear. So hopefully, and Napier was not good, for example, when I was last time. So, but 10 days is far away, and when I looked at the 15-day one, it was all rain all over New Zealand, so difficult. And that's the challenge with that weather prediction for eclipses, transits, and lunar eclipses, especially when it's such a short one. It's yes, when it's a longer one, you can have clouds in between and still see it, have luck, yeah. So and there are certain weather applications I can use in Android. That's the best one. And interesting, the weather channel and they differ. So here was Auckland cloudy, but a little bit sunny spells, and here was sunny. So the question is what they should believe. That's tricky. So to predict the weather in New Zealand is difficult, especially I think Auckland, Northland is pretty the same. And yes, and at the end you need the right location and time. Here a good reference is timeanddate.com. You can in the internet, and you can get all the times for the exact location. That's really good to prepare. Then the Canon I've shown, and then, yeah, weather forecast, where to go. And then if you want to travel for it, you are planning travel time of work. I took some holidays now from work, otherwise I wouldn't be here. And then, for example, in the Napier eclipse, the last one I saw, I planned it directly in the Blue Water Hotel because I thought that's the best location. And from the balcony, you can see all the moon from early stages up to the end. And the weather forecast was only reasonable well for Napier at this time. It was very challenging then. And then, of course, the right equipment for imaging, like tripod mount, camera, so it's all prepared as well. So now, I want to talk about photographing of eclipses. Any questions to what I said before? Anything? No, it's all clear. You can do Whitefield or close-up with telelens and telescope, what I did. And for that, you need a tracker. You can't do without tracking. With a tripod, you can't get the lunar eclipse sharp. You get the color and all that, but it's not sharp. It takes about exposure 1-2 seconds at least. Depends on the darkness of the eclipse. And then you have the total partial ones and penumbral ones. That's a partial one. You see the partial one here fight with the clouds, but a little bit the color comes out. And then the partial ones, deep partial ones with the turquoise rim. So, and that's the Whitefield multiple exposure from Fred Espenach. So far now learned, I think maybe you can do the started technique. That means you put the camera on. For example, Bluetooth trigger is an attachment on the camera, and you can remote guide the camera, and it can make start rails. So you have the exposure and then interval, and then you can get the start rails, and this same technique you should use to get this Whitefield. I may try that out. But again, if it's very cloudy and so, yeah.
You wouldn't need to do tracking for
No,
that wide
no, for
field
the-
imaging.
No, no tracking, no.
How
That's-
long between each of those
That
exposures?
it was that I must work it out. That should be, I would say, minutes or something. Yeah? Would say it's possibly as you like at the end. It should be only important is that you don't have the exposure so that the moon's touching one another. So you need some space between the moons. Yeah. So that's the mounts for the lunar eclipse. For the moon, I use the same mounts as for the sun. So except the solar quest, I can't use. But maybe cheeky and try it out if the sensor reacts to the moon, but I fear it may not work because the GPS is from the GPS coordinates of the moon and the sun are different. So, but otherwise would be handy, quick setup, and can go with small scopes. So and then I use the camera, and here for close-ups you need a tele-zoom lens, or you can use a telescope as well, the 60 millimeter refractor attached with a camera is also okay, yeah. And then the Ioptron Sky Tracker or the Ioptron Sky Guider Pro, I think is the best tool for photographing of that lunar eclipse. You can align it north with the south, and then you get the tracking. Due to the short exposure, if it's not 100% accurate, it may not be such a big issue. If you have longer exposures, of course, must be the tracking accurate. Especially when you have a deep lunar eclipse, you need 8 seconds exposure time. Yeah.
How many seconds?
Pardon?
How many seconds exposure time?
8 seconds. Yeah, that's the recommendation from Espanach. The focal length, so that the field of view and size of the moon images is, of course, depends on the focal length of the lenses, yes. And for example, I have a 300 millimeter lens, so it's in between, it's about 2.4 millimeter. Good, I can then crop it up a little bit, then it comes up as a digital twice, and that comes up very nice. So that's the focal length, there's image size for lunar eclipses. It's similar for the solar eclipses, it's a similar principle, yes. That's for full frame cameras, and that's for DSLR as a crop factor. Micro Four 30, they have it's half of the full frame. So that means I have a Micro Four 30 300 millimeter, so the 300 millimeter would be around that one, a little bit bigger. So that's the exposure guide. I referred to it before. So when you have a very dark eclipse, up to 8 seconds, depends also on the F number and on the ISO. But if you give too high ISOs, you get the noise. So that's always a trade-in with too high ISOs, the noise. So with a Micro Four 30, with my camera would be 200 up to 400 ISO, the maximum I should use. So for example, that Danjon value can be 8 seconds or more, up to 8. When it's very dark, like 0, almost black, then it may take minutes, but that's very rare. Normal, we have that stages. L4, that's about up to, depends on the F5, 6 numbers, 8 seconds. Normally, yes. That's what I have in the tele lens, so the F5, 6, so it would be about that spectrum. And I needed about 2 seconds. I show that now. So here, they now come to the images I did. That was a partial in 2017. You see not much covered by the Earth's shadow, so it's only minor, but it was in the morning, and still a little bit of cover. You see a little bit of color when I overexpose it, and it was in between a lot of clouds, yes. but it was still nice and from my place here. And here, that was an interesting lunar eclipse. It was 5 minutes only. You see the moon is quite on the edge, similar as that one we have next Wednesday. And also the shadow quite small. That was the totality. The 5th of April, and there was this turquoise rim that's often to see. Yes, it was just total, just. And this nice coppery color. And here the exposure was f5.6, 400 ISOs, and 3.6 seconds. So that was what I needed to get this image. And here, that was the highlight, what I could image on lunar eclipses. That was 3 years ago in Napier, the best experience, a so-called blue water hotel, and there was all blue lights there. And it was a supermoon as well, and the weather was touch and go with the clouds. In the north, I think it was mostly cloudy. I don't know if I saw it in Auckland, not sure. So I'm not sure. There's patches where there, I think Raymond could see it in Whangarei just. And so that was touch and go, but it was a longer eclipse, so we had time. So there was 76 minutes, so 1 hour, 16 minutes, so that's pretty good. And it was pretty close to the center of the moon, relatively, and was fully visible in New Zealand here. So that was the penumbral phase, just beginning of the partial phase. I did that imaging with the imaging camera. The penumbral phase comes better out with an imaging camera, with a telescope, put in an imaging camera there, make a video and then stack it together. But you have to do short exposures, maximum 10 seconds. Otherwise you get it blurry due to the movement. So that's the beginning of the partial phase. And then that's the end of the partial phase is here, totality, and then again begin of the partial phase. That was between 1:51 a.m. and 3:21 a.m. It was a very long eclipse, and that were 2 seconds I needed for the partial phases and 2.5 seconds for the total. And
so
that,
when you're doing
and that was tracked. That was tracked with ioptron.
So the total one, you just open your shutter. You open your shutter for 2 seconds.
Yeah.
Whereas the other ones, you do a video.
Yeah, there was a video, but you can do the partial also with the camera, of course, with the camera. But I prefer the beginning of the partial came out better. But it's.
When there's no shadow of the Earth on the moon, of course, the full moon is very bright.
Yeah.
In fact, people don't realise that it's as bright as, say, looking at the ground on the Earth during the day. Yeah. So you use quite a short exposure for the early pictures before the shadow starts to move on to it.
Right.
I need an exposure of the full moon about 1/2000 still with 400 ISOs. Depends how bright I want it, also up to that. Yeah. With f5.6. So that's a little bit in detail. And there was a little bit of haze there, so like an iridescence here. But yes, high clouds. Any queries? Anything? Yeah.
With the tracker,
Yeah.
you're setting it to lunar mode. Does it follow it exactly, or you have to make adjustments?
Yeah. So with the ioptron, if you align it right, north, south and north, you should not have many adjustments. Depends how you do it. And with the Alt-Azimuth tracker, it should also track accurately, but it can drift off. And the field rotation you have to also put in account with longer exposures beyond 30 seconds. So that's the totality, and with the stars, that was very nice. And that was reasonably well tracked. Not yes, and that's a little bit cropped in. So the stars, when it's well tracked, should be completely round. So that's the partial phase. And here I made an experiment. I tried also with my imaging camera with that one, Z174M. It's a black-white camera, so I had to artificially color it, and I couldn't get the color really right. And it was also tricky because it's low. It needed the video. This was very low light. Was not very. You needed high exposures, and so it gets easily noisy. But that was the best attempt. I tried it. We had time at the eclipse about 1 hour to a little bit experiment. Was not. In the totality I couldn't get. It was too dark. Yes, it was not the partial. Yes, the deep partial. Yeah, that's the totality. Couldn't get it well. It's pretty blurry. Yes, so, but I tried it. So, and of course, you have to limit the video time. If you have too long, yeah, it gets blurry, the movement of the shadow. So and here, that's wizard tracking when I was in Christchurch. You see the difference? And that was tracking when Raymond did it at the same time in Whangarei. So it's pretty striking, yeah. And then, future eclipses. Yes, we're coming slowly to the end of the talk. If any questions, please. That's a future eclipse. That was then that was in 2018. That was a partial one I did. That, was pretty clouded in. It was 70%, but I could get only to that one. Yeah, looks not bad. When you overexpose the partial phase, you get the color as well. Yeah, it looks good with the clouds. Yeah, it looks like a time bomb or something. Yeah. So, and then I got another one. That's the only penumbral one I could image before I come to the future eclipse. That was in Napier. Was on a congress. And it was completely cloudy at this day. It was no chance. But at the hotel, I thought, okay, I try to get out, and maybe there's a patch there. Give it a go. Why not? And you see the penumbral. It's also just in the penumbra about 80%. Yeah, in the penumbra. So give it a go in Napier. So that was near my hotel there, the memorial place. And here, that was the weather conditions. I hope we don't have such conditions at the 26th. That's I have to chase around. Yeah. So you see that, it's a little bit of clear patch here. And the nice iridescence of the clouds, yes. So, and I'm waiting for the gapping clouds from that express hotel. I was there patient 1.5 hours. Yes, and I got it. So that's the Penumbra eclipse. I think you may make it up. It's a little bit darker than a full moon. And it was still very bright. That's what I need, 3,200 seconds with 400 ISO f5.6. So still very 300 millimeter. And that's, it was also a blue moon there, so therefore I thought, okay, that looked like the full moon then, yes. I think it's clear that there are no blue moons. Huh? It's only, there's a Photoshop color. They are rare. If there's a very severe volcanic eruption and the atmosphere is fully hazy, the light can refract and maybe you see a little bit of color there, but yeah, it's not likely. But yeah. So now that's the imaging, but also you need some post-processing, also like you can a little bit, it's important to have good images, good focus, good mounted, the right condition, and then in the processing you can a little bit tweak the photos, like get better contrast, crop it, maybe tweaking the color a little bit, comes out more. And if you want to show the blood moon, you can make it a little bit more red, yeah, okay. And you can sharpen reduce the noise, for example, this speckle, but there are other possibilities. And then the lens correction of chroma, defringing, and then you can do composite of the faces like I did here. Yeah. So that's the eclipses they are recent and future, and afterwards I will also show some later on that what was in red that was visible, and the other ones either partial or total visible. For example, that one we missed completely. That was the last lunar eclipse we had, almost 2 years, 4 months ago. And here, yes, here you have different types again. And the partial one is at the 19th of November, is a deep partial this year, almost 100%. That's a really worth seeing, worth going, and we have a little bit more time, 208 minutes, so I have enough time maybe to see something, so that's worse. November, yeah, I don't know the weather in Auckland, November. Yeah, better chances than in May, possibly, I don't know. Yeah. So, yeah, and that's in 1 year, the 22nd of May. That's a good one. I think we see the beginning of the totality, just getting there. And that is a long totality of 85 minutes. So that's enough time to watch it. It's pretty central, the moon in the shadow. So then there's one again in November 2022, full visible in New Zealand as well. It's again late, relatively late, as the other one is in the morning, that one, and that is late, yes. So for working times, not ideal to get up, yeah, if you have to work next day at 11 o'clock, yes. So, and that's a good one. And then is again a gap. There's about 3, 4 in a row, and then is a gap till the moon gets again aligned with the lunar node. Takes again a while till 25. So it's about 3 years, or almost 2.5 to 3 years. Then you have the next eclipse in March 25. And then you have again a Saros in September 25. And in March 2026, that's a good one also for New Zealand. And then in August 28 as well, not so well visible in New Zealand. Yes. So that's all what I wanted to talk about. Is there any questions, any queries? Some minutes time.
When do you find out how high the moon is going to be during the eclipse?
Pardon?
How do you find out how high up the moon is going to be during the eclipse? Like at what angle you're planning it?
Yeah, good. There are applications there. All sky applications. What they use for the stars as well. Sky Safari Plus or something like that you can find out. Then photo pills you can plan. So that's it, yeah. And there are also some moon phases applications enough on the phone to find out the positions. For example, on my place I must be careful because I have the Mt.Manaia and also it's a little bit steep when it's in my time up, yes. And you know the moonrise and the moon set, of course, you can know that as well. Yeah.
Stellarium is a good free...
Stellarium is also, yeah. Yeah.
Find the moon and it'll tell you exactly the altitude.
One thing I noticed with some of your photographs of the partial eclipses is quite interesting that the Earth's shadow is curved on the moon, and the ancient Greeks noticed that, and it was one of the arguments Aristotle used to show that the Earth must be spherical, because no matter where in the sky the lunar eclipse was occurring, the shadow of the Earth was always round.
Must be,
so it's quite interesting. So the knowledge that the Earth was a sphere is very old. It goes back 2,500 years. So I'm not sure where the flat earthers are coming.
Yeah,
Good.
Is there a flat earther here?
I hope not.
Good. And but unfortunately, flat earthers, so you can give arguments, and arguments, from my point of view here, may speak also as psychiatrist, I think it's a delusion. That's a belief, despite the reality proves it different. But it looks like they want to be special, and to fight against delusions doesn't work out. It's escalating. So yeah, I know there's some attempts in there. There's a face group of the flat earthers, and there's possibly some astronomers trying to undermine it with comments. But I looked once in, it's horribly abused sometimes what they put in, and really below the belt, and that's and no, it's like fighting against windmills. It's a delusion, and it's difficult to fight it. I'm not sure. The only way possibly you have to send them to space or something, or with a rocket. But delusion is fixed. And it's a collective one, unfortunately, and possibly more spread in the US. But there's a New Zealand group there.
Why don't we find all the flat earthers and send them on a one-way trip up there to have a look?
I don't believe in rockets. Otto, just a question back on the red moon.
Yeah.
It's to do with the red light refracting back in.
Yeah.
Does all the other colours of the spectrum just get sent off into outer space?
Yeah, that's especially sunset and sunrises. The blue of the sky gets reflected away. So that explains, I think.
It's the same logic as why you've got blue sky. The blue light's getting scattered away.
Scattered away.
If you actually were on the moon when this is happening, when you're looking at the Earth, you're seeing the night side of the Earth, and around the edge is all the sunsets and sunrises. Just as we often see red at sunset and sunrise, you see all of those in a circle from the moon.
All the different colours.
Yeah. Well, it's going to be red around a red, sort of like a red halo around the Earth, and that's what's illuminating the.
It's rarely scattering.
Yeah.
It's a scattering of the blue sky is scattered away, yes, and we see the red. Would be interesting to stand on the moon and see that, but maybe once future.
That brings up another thing. People wonder why the lunar eclipses and solar eclipses actually happen with the same frequency, but you see a lot more lunar eclipses, and it's because you only see a solar eclipse if you're actually in the right place in the track of the moon's shadow, whereas for a lunar eclipse, half of the Earth gets to see it.
That's different.
If you are counting down, it's 8 days, 23 hours, 57 minutes, and 27 seconds to go.
Yeah. So
When is you know, in the old days, how they used to like see a blood moon and they used to think the world was ending. When is a blood moon?
That's what this is.
That's what the eclipse is, yeah.
This is
the blood moon it's the same. It's only the Catholic Church, and sometimes they use the term of blood moon because it's red, or the reddish.
When does it turn red? It won't turn red unless it's the right conditions in that.
It's exactly when there's a total lunar eclipse, that color is reddish, coppery reddish, and it is. Yes, the same thing. It's. Yeah, it's named red moon because it has a little bit similarities with the color of the blood.
So this eclipse, because it's a shallow eclipse, it won't go blood red, it'll be a lighter red. You might go pinky red. But if it's a deep eclipse, like you have an hour and a half long eclipse, it'll go that blood red colour.
But the dead eclipse looks like similar. That eclipse will be looking similar like that one. Similar like that April one in 2015. Similar like that. And that red, it's, I mean, they say the blood moon because it's a symbol of red blood, and yes, but that's the true color of the eclipse.
There were naming things they couldn't explain why it was happening. They didn't know
Yeah,
what was
I
happening, they just had naming things.
So they used to think the world was ending, especially when it used to block out the sun, yeah. They were like, it's all turned dark.
Columbus, the story from Columbus, of course. Columbus got then the food from the natives because he can sort of darken the moon, yes. He knew that the lunar eclipse coming. And, yeah. Yes. And
are you stacking some of these images to reduce noise for a lunar eclipse? Would you do that?
no, that's. I think the problem is with the stacking because the Earth shadow moving too far, it will be possibly not work out well. Yeah. And that's the problem with the video. Yes. No. Yeah.
Would maybe with a longer one would work, or
No. You must short. Got the best. When I have, let's say, a dark lunar eclipse, if it had not happened, if I really almost a black eclipse, then maybe, then it's maybe not so artifacts due to that movement. But
Have you ever tried to like set up like multiple telescopes and capture different types of images?
Pardon?
Like, you know how you had that image where it went from the beginning to the end? That was a really cool image. But if you wanted to capture that image and say some other images, would you have to set up 2 telescopes and 2 cameras?
Yeah, good. I need 2 cameras. One camera I do then the usual one with the tele-lens, and then I have another one. I have 2 cameras now. I want to try that. I have not tried it before, so that's one I want to try this time, like the star trail technique with the Whitefield. And then you get with the star trail technique 1 image, like the star trails. Yes, it's a specific technique. You can use the camera or you can use the software. So that's, you do many images in this software, compiles it in 1.
The trouble with having multiple cameras though is you've got to, all through the process, you've got to be changing your exposures. So trying to work 2 or 3 cameras at once.
You need for the Whitefield a complete, all best the same exposure. For the Whitefield 1 camera, and then you do with the tele-lens the other camera. That I'm planning to do with the Eclipse.
Well, one idea I had, if you getting noisy photographs and you can't afford Lightroom, then there's a free equivalent called Darktable, which has quite a good denoise routine. If it knows your camera, you select denoise profile and it knows the noise characteristics of the camera. It does quite a good job. It's a free program for processing raw images from DSLRs and so on.
Would you get any noise if the exposures you take here to be extremely short, even when it's eclipses that are bright objects? I've photographed lunar eclipses and I've never done any noise processing. I've never had any noise in the photos.
But I must say, I had not much noise in 2018 with the 400 ISO, but I think I didn't do the noise at all. It's more brightness and contrast sometimes. But the core things is focusing and tracking with the lunar eclipse. That's the 2 things you need to.
And going from the long Florida, enjoy the eclipse. Don't sit there all night with gadgets and looking at computer screens. Actually look at the sky and enjoy the eclipse as well.
I must say,
You've got 15 minutes of total depth, 15 minutes of total. So it goes fast when you're trying to operate 3 cameras and 2 telescopes and
I must say that my first eclipse I saw, that was the best one. That was in Switzerland. I must say I had not planned it at all. I didn't know that there was a lunar eclipse, but when I went, so the Kempster Pass, there's a sea, there's a lake, and then there were people there, all quite excited, looking at the moon, and then I said what was there, and that was the first lunar eclipse I saw. Fantastic. That was amazing. And so I got hooked into the eclipses and to look at eclipse photography. So that was my first eclipse. I think in 1996 or something, yeah. That was amazing. So it's an amazing experience, especially when I have it in mouth in the mountain lake. And there was also a little bit of snow there, but I would say Mount Cook would be a fantastic location, yeah. But better permitting. So, yes.